It is now February the 29th, 2012, 1 a.m. early Wednesday morning, and I'm going to wrap this amplifier up. But I want to show you what I've done. And first of all, I want to thank the so many people on YouTube and private emails for the suggestions they have given me on this. It has been fantastic. I never expected it. I'm overwhelmed with good suggestions. Thank you all. Thank you very much. I want to show you what I've done. I've taken all of your suggestions to the point of cleaning the workbench off and starting over and checking all of the screen resistors and grid resistors and the bias, and just kind of like starting over. And at the same time using each of the suggestions. And here's what I've actually come up with. I actually talked to Mesa today. They were very good about calling me and very interested in talking about the problem. I really appreciate that. And I'm going to show you what the final is here, because I got to move on. Can't work on this thing the rest of my life. A couple of things. One is this capacitor right here was pointed out to me. I don't find that one in there. This snubbing capacitor to help stabilize it. I added that one. That was the 500 picofarad. I added 1,000 picofarads across there. I also added, let me go back to here, sorry. I also added feedback from the 8 ohm tap through a 2 meg ohm resistor back to this plate right here. 2 meg ohm resistor from here to there. Now the signal comes in here. This is from master control here. This tube is the first driven tube in the power amplifier section. This cathode drives this grid, or I'm sorry, not this grid. This cathode drives this stage right here, which is grounded grid. Right there, grounded grid. So you get your phase inversion grid to plate, and then the phase inversion here is not and not, so you end up with the two phases here opposite driving the output tubes. This just shows 2, but there's actually 12 in there. So the only place I could find where it was out of phase from the output back to some feedback point was actually this plate. I put a 2 meg ohm resistor. I'll show you here. Right here. That little guy, I can't stick my finger in there. It's actually turned off, but this little guy right here. And then I ran it back to here. The snubbing capacitor added is right here. The snubbing capacitor is a 001, 1,000 picofarads. And it's this guy right here. This has stabilized it. I can't show you, every gory detail of how I got there, but this is where I got, and I'll show you the results. So let me lay this thing down. And one other thing, one fine gentleman pointed out that one of the things that could possibly be wrong with it is this Zener diode right here was shorted, completely shorted. This is a new one, but the Zener diode is right here. Actually, I'm glad it's still in this schematic. It's right there. That Zener diode was shorted. That's going to reduce the voltage by 15 volts from 480, because it's a 15 volt Zener diode, to 465 on the screens, and it does indeed. I think in the earlier video I made of it, I made these measurements, and I think it came out to be the same because it was shorted. So that was one thing. That didn't make a lot of difference. It may have made some difference. I think a combination of several things have actually stabilized this amplifier. So I'm gonna have to lay it down here, and I'll hook it up, and I'll show you what the results are. Okay, now that she's laying down, if I put this in free run and I drive it at 100 hertz, I've got everything set to the middle. Mid, middle, bass, treble, master, well, whatever. Set it wherever you want. I'm going to leave it up here kind of loud. I think my client runs it pretty high. I'll leave it at 7 or 8 where I just had it. I'm driving it input 1. Volume 2 is all the way down, input 1. Okay, 100 hertz. Here's what we get. There it is. All the way up to clipping. All the way up to about 10%. There we go. That worked out nicely. 36.7 volts. You can do the math. 36.7. I'll do the math here. This is at 101 hertz. 36.6 squared for divide. There it is. 334 watts. At less than 10%. Very nice. Easy to drive. Okay. That was no big deal. Here it is again on another scope, just for the fun of it. I'm going to turn it down, and now I'm going to gate it what way I've been testing this thing all along. 100 hertz gated at 10 hertz. Triggered at 10 hertz, so that I'm thumping the guitar, so to speak. And here's my output. Turn it up, 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 up. All the, wow, look. It's not total magic. Clipping horribly. I mean, I'm overdriving this thing to insanity. If I put this in free run, look, I'm putting out a square wave. 42.6 volts at 30% distortion. Well, it's a square wave. What do you expect? You can figure 42.4 squared divided by 4, and you can figure the power. But so I'm overdriving it to the point of insanity. But here I am pulsing it again. Now, these changes that I've made have made a significant difference. And like I say, I can't show every teeny step along the way. But what I have learned, I used a current probe on this thing earlier. This thing right here. And I could put a one-turn loop in it and lay it right here on the transformer. Just lay it right there with a one-turn loop of wire in it. And I could see that this thing puts out an enormous magnetic field, which I'm not real happy with, since it's right here on top of all these little coils. Right down there, those little things with the white labels on them are coils. So this thing is inducing some voltages into there. I know it is. But I got to live with that. You know, I can't rebuild this thing from scratch. And secondly, look where I've got the tone controls. Now I'm driving it at 100 hertz. This is in the mid. If I do just the slightest bit of contouring, it works. Yes, I can still send this thing into shock. I can still send it into oscillations. But this right here is my documentation of what is actually working. And you can see what I'm driving it to. It's actually kind of working. Now, if I start raising this is the 250 hertz one. See, I got 40 hertz, 100 hertz, 250. My fingers anyway. 625, 1560, 3900, 6800, 6600. If I raise all these things up, I can throw it back into oscillation. There it is. It's trying, but it is so much more stable than it used to be, with just a reasonable amount of contouring or lack of gross overdriving it. It actually seems to work quite well. So that's my final solution, and that's where I'm going to put it back together, have a discussion with the client, and hopefully go forward, because I have to move on. I can't, as I just said, I can't work on this thing the rest of my life. Doing amazingly well. Look at that. That's pulsing. 100 hertz gated at 10 hertz. Free running. Square wave. 42 volts across 4 ohms. Back this thing down to anything with insanity, and it actually works. There it is. So that's the solution. And again, once again, oh my, God, thank you all for so much help. I never expected such a response. I hope that this helps others. I'm not recommending that everybody do this to their amplifier, but it does seem to have improved this particular one.